In this video, we're focusing on arithmetic sequences. And to see what makes a sequence arithmetic, it helps to put one next to something that looks similar, but isn't. Both of these start at 5, but look at how each one grows. What's different about the pattern? On the top row, we're adding 4 each time. On the bottom row, we're multiplying by 2 each time. And that's the whole distinction. Arithmetic sequences have a common difference. Geometric sequences have a common ratio. This video is about the arithmetic kind. So for our sequence, the common difference is 4. We call that D. And here's the formula for the nth term. A sub n equals a sub 1 plus n minus 1 times d. A sub 1 is the first term. D is the common difference, and n is which term number you're after. What makes this formula worth having is that it jumps straight to any term you want, without listing out every single term before it. Example 1. Find the 12th term of 5, 9, 13, 17, and so on. Start by writing down what you know. The first term is 5, so a sub 1 is 5. The common difference is 4. And we want the 12th term, so n is 12. Substitute those in. 5 plus 12 minus 1 times 4. 12 minus 1 is 11. 11 times 4 is 44. 5 plus 44 is 49. Example 2. A sequence starts at 8 and has a common difference of -3. Find the 20th term. So a sub 1 is 8, d is -3, and n is 20. 8 plus 20 minus 1 times -3. 20 minus 1 is 19. 19 times -3 is -57. 8 plus -57 is -49. Notice the formula doesn't change when d is negative. The sequence just decreases instead of increases. Example 3. Now we'll work backwards. Which term of 6, 11, 16, 21 is equal to 101? This time we know the answer, and we're solving for n. The first term is 6, and the common difference is 5. So 101 equals 6 plus n minus 1 times 5. Subtract 6 from both sides. 95 equals 5 times n minus 1. Divide both sides by 5. 19 equals n minus 1. Add 1 to both sides. N equals 20. So 101 is the 20th term. Last one, and this is the kind of context question the exam likes. A theater's front row has 18 seats. Each row behind it has 3 more seats than the row in front. How many seats are in the 15th row? The front row is our first term, so a sub 1 is 18. Each row adds 3, so the common difference is 3. And we want the 15th row, so n is 15. 18 plus 15 minus 1 times 3. 15 minus 1 is 14. 14 times 3 is 42. 18 plus 42 is 60. So there are 60 seats in the 15th row. Once you're comfortable finding individual terms, the next video covers arithmetic series. That's adding all of those terms up, using the same a sub 1 and d.